Welcome to Project Tornado. I'm ABC 57 First Warning Neighborhood Weather Chief Meteorologist Tom Coombs. My job is to tell you about all kinds of weather. The nice days, the rainy days, snowy days, and those few days a year with severe weather. If a tornado happened today, what would you do? Where would you go? Do you and your family have a plan to stay safe? The best way to be protected is to be informed, know the forecast, and know where to go. Project Tornado is severe weather preparation and education. We're going to learn about thunderstorms, lightning, hail, flooding, tornadoes, and of course, finding your safe spot, and more. Thunderstorms can be loud. The booms, bangs, and pings can be startling. But what puts the thunder in thunderstorms? Meteorologist Emmett Toomey explains lightning and hail.
Let's talk about lightning and hail, two of the most essential components of any thunderstorm, whether it's severe or not. First, we're going to be talking about lightning. But before we get into the actual thunderstorm, I wanted to first bring up a concept that a lot of us might be more familiar with, especially as kids, which are magnets. When you have two magnets of the same charge and you put them close together, they're going to repel each other because they have the same capacity. But if you take a magnet that's positively charged and a magnet that's negatively charged and hold them together, they're going to be more attracted to one another. And those opposite charges are exactly how lightning works in the same concept. You're going to have negatively charged particles in the atmosphere and the cloud. That's these blue electrons here in that thundercloud. And then red positively charged particles at the surface. These are constantly trying to connect with one another, and that will form lightning, but it takes time for this to happen. You're going to see these negatively charged blue particles reaching towards the ground and those red positively charged particles reaching up from the ground here. And they're eventually going to be meeting, creating a powerful electrical current that can be almost 6 times hotter than the sun. Now, this all happens very quickly within the span of less than a second, traveling at 60,000 miles a second. We don't see the initial connection of these positively charged and negatively charged particles, but we do see the return stroke, and this can happen within less than a second, almost a blink of an eye. Past that, you want to make sure you're heading indoors during any kind of lightning. Whether it reaches the ground or not, if you see that flash, it's not just thunder when you need to go indoors, but lightning as well. And there are various kinds of lightning that we talk about. The cloud to ground is the most common. That's what a lot of us see when we see a thunderstorm. But you can have lightning that hops from one cloud to another. That's a little bit less common. You can have lightning that goes from the bottom of that thundercloud up to the top of it, almost into the outer atmosphere. And then you can have cloud to the sky where that lightning just kind of disperses into other clouds. But if there's any kind of lightning, make sure if you see it, you're able to go indoors, and essentially don't go under any trees. The other big thing you'll notice within a thunderstorm, except for lightning, will be hail. Those balls of ice that fall at our feet and look almost like winter weather rather than summer weather, which is where a lot of these thunderstorms tend to form. How does hail form though? Let's take a field trip inside this cloud here. We're going to be starting with these red arrows. These are updrafts, winds moving from the surface and moving into the cloud, providing the source of lift for those water droplets. Now, as we know, water droplets do form in the thundercloud, but you can see this blue line. This is the freezing level. When water droplets move above that blue line, that temperature is below freezing up there, and it will begin to freeze, turning from liquid to ice. Eventually, it'll rise above that freezing level, it'll freeze, and then fall back down below it and turn back to liquid. So it's melting and then refreezing and then melting and refreezing, gaining these extra layers of water, getting bigger and bigger, kind of like rolling a snowball where that snow is forming on top of itself. Eventually, with all those additional layers, that ball of ice gets too heavy for the updrafts to support it, and it's going to be falling back to the surface where, once it lands, it can come in the form of up to baseballs or even grapefruit. Make sure when you see hail, you stay inside and stay safe.
Wind is wind. It doesn't matter if it's spinning or moving in the same direction. It can be damaging and dangerous. Straight line wind of more than 70 miles per hour can be just as damaging and dangerous as a tornado. When we have any kind of severe weather, there are different kinds of weather alerts that you need to know about. These weather alerts help you get prepared and take action in case of severe weather. Meteorologist Dave Caulfield explains the difference between a watch and a warning.
One of the most common questions that meteorologists get is, what is the difference between a watch and a warning? It can be kind of confusing, but if we think about it differently, it becomes a little bit easier to remember. So we can use tacos. The National Weather Service in Albuquerque broke this down with a taco watch and a taco warning. On the left, we see our picture with all the ingredients there to make tacos. That's our taco watch. Maybe you have tomatoes, cheese, sour cream, maybe even jalapenos. But the tacos haven't been made just yet. The ingredients are there. Now in a taco warning, we're having tacos right now, and the taco is completely made. And so we can think about this when it comes to severe weather. In this case, tornadoes. During a tornado watch, that means be prepared. Conditions are right and the ingredients are there for tornadoes to form in usually the next few hours or so. And that will sometimes lead to a tornado warning. That is when it is time to take action and get to your storm safe spot, your tornado safe spot, wherever that might be in your home or where you are. Now that also means a tornado has either been spotted by someone on the ground or it's indicated by radar. So radar thinks that there's enough rotation there to potentially produce a tornado down the line. Now there's also a type of tornado warning called a tornado emergency, and these are pretty rare, but it is the highest level of tornado warning that the National Weather Service can produce. It means that there is a severe threat to human life and catastrophic damage. Usually we see these when a tornado is moving through a very populated area that could lead to a lot of damage and unfortunately a loss of life. So now that we have this knowledge, we can tell the difference between a watch and a warning.
Tornado. The word itself grabs your attention. It's one of the most powerful forces of nature. The strongest can have a wind speed in excess of 200 miles per hour. It can be more than a mile wide. Those are rare. Most are weaker and only about as wide as a football field and on the ground for a few hundred yards. Meteorologist Amber Twardy explains how these destructive vortices form.
Well, when we're talking about the formation of severe weather, and in this case, the formation of even tornadoes, the first four ingredients that we need to look at are moisture, lift, instability, and wind shear. Wind shear is when we see winds at the Earth's surface that are weaker and maybe in a different direction than the winds that we see higher up in the atmosphere. When this starts to happen, we might see a rotating column of air form. This would be horizontal to the Earth's surface as this starts to spin around. Now, once we get a thunderstorm really coming into the area, we could see that warm air start to rise up in the atmosphere with something we call thunderstorm updrafts. Maybe those updrafts start to take part of that rotating column of air, lifting those up and eventually rotating this column of air to become vertical instead. Now, what we get from this is we start to see the development of cumulonimbus clouds, those big dark clouds that you see during thunderstorms. And even from that, we might start to look out for a rotating wall cloud. These have a lower base in them, a rotating big cloud in the sky, and from these is when we would start to see the formation of tornadoes. Now we start to see maybe some building that happens back towards the Earth's surface, a lot of that starting to stretch towards the ground. If it doesn't quite touch the ground, we call that a funnel cloud. Now if it does touch the ground, that's when we classify it as a tornado. When we're talking about how we rate the strength of tornadoes, we use the Enhanced Fujita scale or the EF scale. On the lower end of things, we have the EF0 tornado with winds between 65 to 85 miles an hour. At this point, we start to see some branches that are ripped off of trees and some shingles that are ripped off of homes, roofs too. Now, as far as the EF1 tornado goes, this is when we start to see winds between 86 to 110 miles an hour. Some more significant roof damage here, but also the potential for some of those windows to get broken and even some exterior doors that could be completely torn off their hinges. Bumping this up one to an EF2 tornado with winds between 111 to 135 miles an hour. Maybe a whole roof is taken off of a home. Maybe we start to see those broken windows, those shattered windows, the door completely gone, and maybe even a couple of cars that start to get tossed around. With the EF3 tornado, this is when we start to look at more significant tornadoes, the larger ones that do the most damage here. Some of those homes that have a lot of exterior damage to those walls, some of these cars that could even be flipped over, and trees that could be snapped in half completely, even the smaller ones being uprooted. An EF4 tornado here with wind speeds that are between 166 to 200 miles an hour, these homes start to be leveled and we start to see these cars that are thrown even further away. Once again, those trees just getting ripped out of the ground, but probably larger trees at this point before we see the EF5 tornado. This is when we have tornadoes that have wind speeds over 200 miles an hour, homes that are completely ripped off of their foundations and swept away, grass that gets pulled up from the ground, and also cars that get flown completely far away, as well as big bigger trucks that could also be seeing some lift in the air. Now, no matter the rating of the tornado, all of them are very dangerous and they should all be taken very seriously because even if it has a smaller rating, it is still very dangerous to you.
Imagine the perfect picture of a storm. You can see the spin in the clouds, even a tornado. The perfect picture of a storm for scientists may not be a photograph, but a hodograph. Meteorologist Dave Caulfield speaks with a scientist who uses hodographs to take the best photograph of the storm.
I'm here with Cameron Nixon. He is a research scientist at the Storm Prediction Center. Cameron, thanks so much for taking the time.
Thank you so much for having me, Dave.
So we'll start with the photography first. When did you know that you liked storms and wanted to capture them on film?
My parents got me a camera for Christmas one time when that was probably middle school. I just, I would start clicking away. I would take pictures of my little pets, my lizard and my dogs. And then I'd also take pictures of the sky. And I think the sky is what really captivated me. Like there's so many different colors and clouds and textures and before I knew it, that was all that was on my camera roll were pictures of clouds. Then, so the traditional Great Plains, right? Texas all the way up to the Dakotas, east to Iowa, and then west to Colorado. I've shot supercells, those big rotating storms, and then tornadoes in most of those states. I think some of the pictures that I'm most proud of come from West Texas, actually. I spent a little bit of time there. The supercells out there, the storms are just so gorgeous out there. So that's where a lot of my good stuff comes from.
You also are a research scientist now with the Storm Prediction Center studying hodographs. If people haven't heard of what a hodograph is or even seen one, can you sort of describe what we're looking at there?
So we're basically taking the wind direction and the speed at each of those points with height. So if you trace it out, it's kind of like a connect the dots game. They're an excellent tool for visual learners who want to get into severe storms. How is our supercell or our storm today going to behave? Could it produce tornadoes? Could it produce hail? All these things are kind of soaked into the hodograph, which is almost like a DNA, so to speak.
What would you be able to tell about a storm just based on its shape?
Meteorologists have focused on hodographs that are big and curved, like maybe a big half circle or a quarter circle. And those are really fun because they yield some pretty large supercell storms, which we like to chase and take pictures of. My first project was actually trying to understand how tornadoes move and can actually change directions along their path. And I actually found that the hodograph actually affected the way these tornadoes moved. So oftentimes you might hear a tornado suddenly change directions. Well, the hodograph has something to do with that. The hodograph, I think, holds a lot of kind of secrets, if you will, about meteorological processes, and we're just beginning to kind of scrape the surface of. It's always a really humbling experience. I've had just as many, failures as I have successes. And it really helps when you're studying these out in the field, right? And you get to watch the storm behave however it wants to, right? Because nature does have that kind of inner. I'm kind of inclined to look at a hodograph before a chase, wonder to myself how my chase could end up or how my storm could look like, and then just see how it all unfolds. And usually it surprises me. And I think better understanding the hodographs will help us better understand and predict surprise events in the future.
If a tornado happened while you were at home, what would you do? Where would you go? It's okay to be scared during storms, but if you're prepared, you can stay in control of the situation. The most important thing you can do to prepare for severe weather is to talk to your family. Have a plan and practice it so everyone knows exactly where to go when strong storms strike. The key is to find the safe spot in your home, but all our homes are different. Your goal during a tornado is to find your safe spot. Your safe spot puts as many walls between you and the outside as possible. A basement, if you have one, is the best place to be. You can pamper your safe spot, have a blanket, have your bike helmet, wear it on your head. You can even store snacks and a flashlight for when it's time to take cover.
If you don't have a basement, an interior room of your house, such as a bathroom like this,
works best in trying to survive a tornado, especially if your bathroom has a tub, because you can get into that reinforced area and, with the help of some pillows and blankets, lie down in the tub with the blankets and pillows on top of you and put as many things in between you and the potential tornado as possible. If you need additional space, a closet in an interior room like this one will also work. Just make sure you don't have any big objects in the closet that could hurt you in case they fall down during the storm.
If you live in an apartment complex, you still need to get away from any major windows facing the outside. Make your way in interior space like a bathtub or a closet. If you live in an upper level apartment of your complex, you need to make your way down to the lowest level possible when you hear a tornado warning. Once you're at the lowest level of your apartment complex, see if one of your downstairs neighbors will let you in. If not, make your way to below the staircase where you can put as much distance between yourself and the tornado outside.
On a nice day like today, we all want to be outside, especially the playground. In the spring and summer months, though, severe weather can happen almost any time. Number one, know the forecast. Number two, in the event of severe weather, have a plan to get from the outside to someplace safe inside. If you're on the playground and a thunderstorm happens, you want to get to safety. You want to move from the outdoors indoors, like a public restroom. Find a sturdy building, get inside, away from windows, and stay there until the threat passes. Tornadoes can happen any time of the day, any time of the year. I remember one November when we had tornado warnings and blizzard warnings in less than a week. But there's a time of day and a time of the year to be more weather aware if severe weather happens. Meteorologist Emmett Toomey talks tornado timing.
Knowing when and where tornadoes tend to form is one of the hardest parts about being a meteorologist. Their unpredictable nature makes things difficult for us, but not impossible. We're able to track tornadoes through the use of climatology. Going all the way back to 1950, we have data and records that do their best to describe every tornado that has happened in the United States. And on average, over 1,300 tornadoes tend to form in our country. We're going to be going through here month by month and explaining why these tornadoes tend to form and where they are in the country, starting with January. Because the coldest air tends to sit in the north closer towards the poles, Michiana is in the coldest parts. We need our winter jacket. There's usually snow on the ground, and tornadoes cannot form in that really cold weather. To the south, though, in Texas, Florida, portions of Mississippi and Alabama, that's where that warmest air is, closer towards the equator. And not only is it warm, but it is very humid and sticky. These are the kind of ingredients tornadoes need for their instability and to get that severe storm rotation. As you move into February, notice these states now beginning to shift a little bit further north. Texas had the most tornadoes in January, but now Mississippi does, turning that darker orange, around 3 to 4 tornadoes per month in the American Deep South. Moving into March, we're now beginning to enter springtime when really warm air is transported northward into Michiana. We're still not in the right spot for tornadoes yet, but notice how Texas now averages about 9 to 10 tornadoes per month historically, as does Mississippi. Missouri, around 5 to 6 tornadoes, and then the rest of the Midwest, only about 1 to 2. Now, we are entering deep into spring. In April, this is the month where the most amount of violent tornadoes tend to occur. Not always in Indiana or Michigan, but in Illinois, about 9 to 10 tornadoes on average. You move into May, this is where the most tornadoes happens in any given month, historically going all the way back to 1950. These tornadoes can happen anywhere, and because that warmer air is being lifted further north as we're entering springtime and summer, things are getting hotter at the surface, and we create that instability and those right ingredients we need for tornadoes to form. Moving into June, this is where the most amount of tornado days tend to occur. Now that warmest air is closer towards that U.S.-Canadian border, and Michiana is currently at its hottest point it likely will be all year. As you go into July and August, this is where we really tend to see severe weather ramp up. Not always tornadoes, but thunder, lightning, and hail. You can see Indiana only about 1 to 2 tornadoes, but North Dakota and Minnesota, 9 to 10 tornadoes, even more than that at any given point. You move into August, now that warmer air is starting to retreat back towards the south because we have hit our peak heating for the year. Indiana, Illinois, now starting to see only 3 to 4 tornadoes, and that warmest air going to return back to the south, closer towards the pole as we're getting ready for winter. You move into October and November, now Texas is getting brighter again because that's where that warmest air tends to retreat. As you move into November and December, tornadoes generally don't tend to happen in Michiana. That's not to say it's impossible, but it is very unlikely. Going to December, tornadoes now unlikely to happen in most places across the United States. It is just too cold. That warmest air is staying too far towards the equator. Timing is everything. When do tornadoes happen during the day? Most often, tornadoes tend to happen from 4 p.m. to 9 p.m. From the time you get home from work or school to the time you go to bed, that late afternoon, early evening hour is prime time for these tornadoes to form. Those surfaces like blacktop and concrete are at their hottest, and you have the right ingredients for severe weather. But tornadoes can happen anytime and anywhere. And that's what Project Tornado is hoping to do to keep you safe and keep you prepared for the threat.
For a long time, flash flooding seemed like more of an inconvenience than severe weather. In August 2016, that all changed.
Reports and estimates so far topping 4 to 5 inches of rainfall, and that's why we're breaking in. This is what I would actually consider a flash flood emergency. This is the worst flooding that I have seen.
But it keeps happening. I'm in an empty parking lot in Mishawaka. Back in July of 2021, this very spot was far from dry. More than 4 inches of rain fell in just a few hours' time. During heavy rain and flash flooding, seek higher ground. Stay out of the deep water. You don't know how deep or dirty the water is, or worse, you could be washed away or even drown. Heavy rain and flooding is now a more regular occurrence. 4 of the 5 wettest days in South Bend history have occurred since 2008. A warmer climate means the atmosphere can hold more water. Michiana is not alone. More rain means more flooding for many parts of the United States. Thanks for watching Project Tornado. And remember what you learned here today. Remember to talk to your family about finding your safe spot and practicing your severe weather drill at home. And when severe weather hits, turn to the ABC 57 First Warning Neighborhood Weather Team on air and on the ABC 57 First Warning Weather app to keep you safe. For the ABC 57 Weather Team, I'm Chief Meteorologist Tom Coombs. Thanks for watching.